Okay, so remember that step 1 is about symmetry. So let's practice this again. So remember, for even symmetry, we replace f of x, or x, with negative x. And then we simplify. So here, if we take negative x and we multiply it by negative x, we would get x again, x squared. And same here, if we take negative x times negative x, we get x squared. So this is the same as this. And that tells us this is even. And remember that even means it's reflected across the y-axis. So that tells us that whatever's on this side is also going to be on this side. Okay, so let's write that. Let me write this up here. And create some more room. Okay, in the last problem also we had to check odd symmetry, but if we already know it's even, we don't have to check odd because it can't be both. It can only be one or the other or neither. So now let's look at our step 2, which is y-intercepts. Remember, with y-intercepts we're making x equal to 0. So we'd have 2 times 0 squared over 0 squared minus 9. So 2 times 0 is 0. 0 minus 9 is negative 9. And 0 over negative 9 is just 0. So this tells us that on the y-axis it's going to cross at 0. This is the point 0, 0. Step 3 is the x-intercept. Remember, this is where we make y equal to 0. So we'd have 0 equals 2x squared over x squared minus 9. We'd want to multiply both sides by that denominator to cancel it out. And on the left, that gives us 0 equals 2x squared. We divide both sides by 2. And 0 over 2 is still 0. And then we take the positive and negative square root. But that is still just 0. So again, this gives us that same point, 0, 0, right there. So again, let me create some more space for the last couple steps. So let's look at now at step 4, and that's our vertical asymptotes. So to find the vertical asymptotes, we take the denominator and set it equal to 0. This can be factored. Set each factor equal to 0. We'll subtract 3 from both sides. X is equal to negative 3. And then we'll add 3 to both sides. X is equal to 3. So this gives us 2 vertical asymptotes. Remember, that's a dashed line, up and down line. It's going to cross, the first one will cross the x-axis at negative 3. And the second one will cross the x-axis at 3. And again, it's crossing out those x values because those x values are what would make the denominator equal to 0, which we can't have. Step 5 is the horizontal asymptote. Okay, so again, that's about the degree. Here, the degree on the top is 2, and the degree on the bottom is 2. So we use the coefficients. So that's 2 on the top and a 1 on the bottom, which just tells us that y is equal to 2. So that means we're going to put a horizontal line at 2. Okay, so let me erase some things and so we can talk about what we've got here. Okay, so these vertical asymptotes break our graph up. There's a piece over here, there's a piece between the lines, and there's a piece over here. So we don't have a lot of information here. All we have is a single dot at 0, 0. So we're going to need to find some other points. So let's first of all, let's choose an x value over here on this end. So maybe let's say x equals 5. So step 6 is points. We're going to choose, let's say 5. And we'll plug 5 back into that equation up there. So we have 2 times 5 squared over 5 squared minus 9. 2 times 5 squared is 50. And 5 squared minus 9 is 16. If we take 50 divided by 16, we get 3.125. So that tells us that we have this point 5, 3.125. So we could go over 5, up 3 and a little bit more, and we'd have a point. Now, at the very beginning, we said that we found that this graph had even symmetry. That means that if there's a point that's to the right of the y-axis 5 and up 3.125, if it's also a point to the left 5 and up 3.125. Now, even symmetry, remember, means that we fold it along the y-axis and whatever's over here has to come off over here. So this automatically gives us another point, -5, 3.125. And that helps because now that's all we need to draw these outside pieces. As it goes towards the outside, further left or further right, it should go towards the horizontal asymptote, that orange dashed line. So it's going to go like this here and like this here. Now as it goes towards the inside, it has to go towards the vertical asymptote, so it's going to curve up like that and up like that. And so right there, from one point, we got a second point, which allowed us to graph both the outside pieces. So now let's look at this inside. Let's find a piece on this side of that dot. Let's say x equals 1. So let's put that into that original equation again. 2 times 1 squared over 1 squared minus 9. On the top, that gives me 2. On the bottom, that gives me -8. So if I simplify that, I would have -1/4. So that point is -1/4. So we go 1, -1/4 would be like right there. But remember that also gives us another point, because if it's this side 1, it has to also be this side 1 because of the even symmetry. So that means that we can now draw this middle curve. It goes down towards the vertical asymptotes on both sides. And that's our graph. Let's do one more. So again, we'll start with symmetry. So again, remember, for even, we replace x with -x and simplify. And this, again, matches this first one, so we know that we have even symmetry. Okay, that's going to help us because, again, it remembers that anything we get on the right will also be on the left. So now let's look at step 2. And step 2 is our Y-intercept. So remember that the Y-intercept says that we're making x be 0. So we'll have y is equal to 0 to the 4th power over 0 squared plus 2. So this gives me 0 over 0 plus 2, which is just 0. So again, I have this point right here, and I know that now my Y-intercept is y equals 0. So let's look at step 3, and that's our x-intercept. Remember that that means we're making y equals 0. So we have 0 is equal to x to the 4th over x squared plus 2. So we'll multiply both sides by x squared plus 2, because that's the denominator. We want to cancel it out. But that just gives me 0 is equal to x to the 4th. And we're really taking a 4th root here, but it's just going to give us x is equal to 0. So our step 3, x-intercept, just told us that x was also equal to 0. So that, again, just gives us that same point right there. So let me clear off some room so we can get our asymptotes going. So step 4 is our vertical asymptote. Remember that means we take the denominator and we set it equal to 0. So subtract 2 from both sides, and I get x squared is equal to negative 2. I could take the positive and negative square root of both sides, but what that tells me is that I get this I underneath the square root. Well, the I is not underneath the square root, but we have an I because of the negative underneath the square root. And because this is an I answer, we don't have any vertical asymptotes. So there's no vertical lines in this problem. So now let's talk about our horizontal asymptotes. We use the degrees of the top and the bottom. Remember, the degree in the top is 4, the degree in the bottom is 2. And because the top is bigger, there's no horizontal asymptotes either. So basically, we don't have a whole lot of information going for us. We're just going to have to plot some points. Now remember, back in the beginning, we did find that this graph was even, so that's going to help. That means we only have to have points on one side. So let's just start maybe with x equals 2. So this would be step 6. So we'll put 2 into our problem. 2 to the 4th over 2 squared plus 2. 2 to the 4th is 16. 2 squared is 4 plus 2 more is 6. If we do 16 divided by 6, we get approximately 2.7. So we can plot this point. This is 2.7. So it'd be like right there. But remember, because of the symmetry, it also means that we have negative 2.7. If it's to the right 2 and then up 2.7, it's also to the left 2 and up 2.7. This 2.7 would be a little bit above half. So let's do it sort of right there. Maybe we do one more. Maybe we say 3. So if I put 3 in, I get 3 to the 4th over 3 squared plus 2. 3 to the 4th is 81. 3 squared is 9 plus 2 is 11. So we'd have 81 divided by 11 is 7.4 roughly. So it tells me I have 3, 7.4. So that's going to be up here somewhere. And then again, it would be the same thing over here. So our curve is going to go something like that. And it looks a little bit like a parabola in this case.